What up, athletes? Let's do this today. This is Module 7, 9.2.1, and our essential question is, what if more than one value of x works? What if more than one value of x works? Now, there's a little activity at the top of this page that is not going to matter much for you, so because you're in distance. So this is a little activity we're going to do as a class, but you can still read through it, kind of understand. Basically, I'm just going to have kids stand up, represent number lines, and as we solve some problems below, they're going to actually act it out a little bit. So don't worry about that now. But let's define some things first. First, remember the inequalities are, so when we see this, this is the less than sign, less than. Right here we have greater than. Over here we have less than or equal to. And then we have greater than or equal to. And when we're actually doing graphs over here on these number lines, you're going to use either an open dot or a closed dot. And the open dot means less than or greater than, not equal to. I'll explain that. And then the closed dot is going to be less than or equal to, or greater than or equal to. One or the other. We'll talk about that. So, first things first, let's take a look at this. What if I wrote down x is greater than or equal to -2? What if I wrote down x is greater than or equal to -2? Well then, first of all, this tells us which dot we're going to use. We're going to use the solid dot, because remember it's the less than or equal to or the greater than or equal to. Okay, and where are we going to use it? We're going to use it at -2. So at -2, I'm going to put a solid dot. Boom. And then where is the values of x that are greater than or equal to 2? Well, -1 is greater than or equal to 2. 0 is greater than or equal to 2. So this side, so I'm going to draw up and an arrow over representing all the values of x that are greater than or equal to -2. And that's all we're doing. That's it in the handbasket. So let's look again. What if I give you x equals 3? Well, we're going to draw a solid dot at 3, and that's all we're going to do. X equals 3. It's a single point. Only one value of x there. Let's try x squared is greater than 4. This one's actually more challenging. So, I'm going to do a little sticky note. You can work it out on the side somewhere, maybe on a side piece of paper or something, but I want to show you this. We'll talk more about this at a later date, but check it out. If I have x squared is greater than 4, I could take the square root of x squared, and I would have x is greater than 2, right? But I have a question for you. What if I use -2? Isn't -2 squared also positive 4? Isn't -3 squared positive 9? So that's greater than 4. See how that works? So we're going to talk about this. Here's what this looks like. So let's think of numbers. Is 0 squared greater than 4? No. Is 1 squared greater than 4? Nope, it's just 1. Is 2 squared greater than 4? No. It is 4, so we're going to put an open dot right there. Because anything after that, 3 squared, is that greater than 4? Yeah, that's 9. 4 squared, is that greater than 4? Yeah, that's 9. So we're going to put an arrow up and to the right. Remember what I told you? What about -2? Now, negative 2 doesn't work because negative 2 squared is 4. It's not greater than 4, so we're going to put an open dot there. But anything to the left of it also works because when we square it, it becomes positive. Like negative 3 squared is still positive 9. That's greater than 4. Negative 4 squared is 16. That's greater than 4. See how that works? And even the decimals in between are always going to be greater than 4. So there are times where we're going to have a number line going both ways. Don't let that trip you up too much. We'll talk about it more at a later date. And then last but not least, what if I have something with boundaries? So we had one going one direction. We had a single point. Now we've had two opposite directions, right? Because there's two different pools of x values that will work. In fact, almost all x's work, just the ones in between negative 2 and 2 don't. And then the last one, what if I give you something that looks like this? Negative 1 is less than or equal to x, which is less than 4. This is a boundary problem. I'm literally defining two left and right boundaries. So first of all, I'm saying, let's read it from x's perspective. I'm saying x is greater than or equal to negative 1, right? Because the big end is pointed at the x. So x is greater than or equal to negative 1. So let's go to negative 1, and it's an or equal to, so we're going to use a closed dot. And if it's greater than or equal to negative 1, we're going to do our arrow to the right. All right? But I'm also saying x is less than 4. So less than means open dot. I'm going to go up and I'm going to do an arrow to the left. Now, our trick is finding out where are both of these true. Well, they're both true where the arrows cross. That's why I'm going to fill this in. Don't have to be perfect about it. Okay? So that is how we would graph a boundary problem. All right. Now, what happens when we need to actually solve this inequality? All right. So we're going to solve the inequality x plus 5 is less than or equal to 8, the same as you would solve the equation x plus 5 equals 8. What do I mean by that? Well, if we had x plus 5 equals 8, what would I do? I would just subtract 5 from both sides, and I'd have x equals 3. Well, guess what? Turns out, if I'm going to solve the inequality, I solve the same way. X plus 5 is less than or equal to 8. Still going to subtract 5 from both sides. The only difference is I'm going to get x is less than or equal to 3. And then when we solve it, if it's an inequality, we need to graph it on a number line. Now, I don't need you to make these big, long, involved number lines. What is the only value of x I actually care about in this? 3, right? So should I make a little line, put 3, and what does it say? Less than or equal to, which tells me it's a closed dot, right? Closed dot, and less than's to the left. There we go. Boom, right there. Got some good homework on back. Make sure you read directions, do everything it says. And with that said, peace out.